I'm Srini Devedas. I'm a professor of computer science at MIT, where I've been teaching for the last 26 years. I sit in the Computer Science and Artificial Intelligence Laboratory. I work in computer architecture and computer security, and at the intersection of those two fields. Over the past 10 years, I've focused on how we could develop secure processor architectures to solve cybersecurity challenges. Cybersecurity is a huge field, and the types of attacks that are carried out by malicious entities on software systems and cyber physical systems that are a combination of software and hardware has only grown over the past 10 years. I'm particularly interested in the intersection of computing system research and cybersecurity, and to be more precise, I'm interested in how hardware platforms, which are obviously essential to run any software, can help with solving cybersecurity challenges. I'm a computer architect, and I've done many projects or developed many processor architectures that have performance features and energy consumption features. But over the past few years, I've been looking into how we could design hardware mechanisms into processors that would help with making software less vulnerable to attacks over the internet or even insider attacks. So one example of this is being able to work on encrypted data. So you can imagine that the only entity that actually touches the exposed data or the decrypted data, which actually can be read, is the hardware processor. And software gets to manipulate this data. The hardware does it for the software. But if software attempts to write this data out, the hardware mechanisms will ensure that the data gets written out into a file system or a disk in an encrypted way. So if an attacker looks at the file system or looks at any memory that stores the client data, they would see an encrypted version of the data, not the exposed private information. I mean, it feels like every week we hear about 56 million credit cards being stolen because of an attack, which was discovered 3 months after it happened. And it feels like there's these mass breaches of security that don't just affect an individual, you or I, but affect just a huge number of individuals. And the reason this happens, well, there's many reasons, but one reason this happens is because you have all of this information stored in a database on a disk, and that system has been compromised. Now, it's not that someone grabs the disk of data and walks away with it. That's actually fairly difficult to do because of physical security. But what happens is that you need to access that data if you want to process credit card information. If you want to be able to run a Target.com or a Staples.com or what have you, consumers are storing their credit card information on the site because they like the idea of not having to type it all the time. And that information has to be read. You have to sort of invoke the credit card number in order to process the transaction. The software has to do that. So if all of this is done properly, then typically what happens is that there's access controls built in that say that the consumer has to log in to his or her website in order to access that particular credit card, which is one of the 56 million credit cards that is stored on disk, right? But if somehow that access control gets broken, then there's a way of a malicious program grabbing all of those credit cards and walking away with them effectively. So how can hardware help, right? So the idea is that what is stored in memory, generally speaking, and you can go to the point where you say everything on disk is encrypted. You could even set it up so what's called dynamic random access memory, DRAM, which is really the memory on your processor that's used. You could ensure that everything in DRAM is also encrypted. The hardware has hardware encryption that encrypts data that leaves the processor and decrypts data that comes back. So what this means is that you've constrained what can access unencrypted information, and you can ensure, for example, that if there's a piece of software can't go violate the access control mechanism and grab all of this data that's sitting on disk. If it did it, it would get 56 million encrypted credit card numbers. And so the details, obviously, the devil's in the details, but that's gives you a sense of what hardware can accomplish. When you work in computer system research, you work typically at layer of abstraction, and computer systems have many layers. Just as an example, there's the processor layer, which is something that I work on, and then you have compilers on top of them, you have operating systems on top of them, and then you have applications on top of them. The collaboration that I'm involved with in the context of NG-HPCC is a computer systems collaboration where I work with folks at other universities and at MIT who are software researchers who work on compiler research and work on operating systems research in particular, and we try to create a holistic design that has security properties from the ground up, from the hardware all the way up to the application.